one, here's another one where I'm not seeing infinity showing up in any of the bounds. Let me erase the remnants of my last problem. But if you're paying attention to your function, this is an x plus 4, x minus 4. It has vertical asymptotes at plus or minus 4, so this is actually a problem. So we're going to want to stop short of 4. I'm going to go ahead and use a variable to do that. We're going to stop at b, and we're going to imagine b is just a little bit smaller than 4, and then we're going to sneak up on 4 from the left. So this is x plus 4, x minus 4. And now we're ready to actually integrate. And again, if you have that factorable denominator and nothing to cancel out in the top with a substitution, that's going to be a partial fraction. So I'm going to say I have 1 over x plus 4, x minus 4 equal to a over x plus 4 plus b over x minus 4. And then I'm going to multiply both sides by x plus 4 and x minus 4 and get 1 equals a times x minus 4 plus b times x plus 4. And if I let x equal 4, I get 1 equal to 8b. So b is 1/8. And if I let x equal negative 4, I get 1 equal to negative 8a. So a is negative 1/8. So back up here, I really have the limit as b approaches 4 from the left of integral from 0 to b. Probably don't actually need that bracket of, which is a. Negative 1/8 divided by x plus 4, and then a 1/8 divided by x minus 4. Sorry, it's weirdly crooked. You probably can't see it, but my record bar is right in the way. Okay, so antiderivative, let me go ahead and block this off. Of all that mess is going to be negative 1/8 natural log absolute value of x plus 4 plus 1/8 natural log absolute value of x minus 4. And we're going to evaluate from 0 to b. I don't know if it's helpful or not helpful. But we could look at this as, if we factor out the 1/8, and I'm going to put the negative 1 last. So we have a natural log of an absolute value of x minus 4, and then minus natural log of the absolute value of x plus 4. I feel like this is going to make it a little easier to spot. We can use the log property again to make that a quotient. So we're going to get 1/8 of the natural log of x minus 4 over x plus 4, but we're plugging b in. So b minus 4 over b plus 4. And then we're going to have minus 1/8 the natural log, and now we're plugging 0 in. So absolute value of, what am I doing? 0 minus 4, negative 4, over absolute value of 0 plus 4, which is 4. So this is natural log of absolute value of negative 1. So natural log of 1, which is 0. So this actually goes away, and I can just focus on the limit as b approaches 4 from the left. Okay, so if b is really close to 4, on the bottom of this fraction, we're going to have something really close to 8. And on the top of this fraction, we're going to have something really close to 0. So inside is going to 0. If you take the natural log of something really close to 0, you're going to get something really close to negative infinity. So it looks like, in this case, the whole thing diverges. Dividing by 8 is not going to fix an infinity, so we have an integral that diverges. So we are not capturing finite area. Okay, thanks for watching.